Hi everybody, this is Algebra 2, Lesson 57. In this lesson we're going to learn ideal gas laws. Alright, so the general equation for ideal gas laws is P1 V1 over T1 equals P2 V2 over T2. What does all that mean? Well, our P stands for pressure, V stands for volume, and T stands for temperature. And this is about when a gas heats up, its volume increases or the pressure increases. So these are going to be proportional to each other. If we take out one of these, let's say that we take out the volume stays the same, then we would just be left with that equation. If we take out the pressure stays the same, we get left with that equation. And if we take out the temperature, we end up with that equation. So these are just the exact same equations, just with one of the variables taken out. For pressure, the units that we're going to use are going to be newtons per square meter, atmospheres, milliliters of mercury, torrs, and pounds per cubic inch. For volume, it may be liters, milliliters, or cubic centimeters. For temperature, it'll be kelvins. And then for pressure, a pascal is the metric unit for pressure, and it's abbreviated as PA. The units don't matter. We're not going to use the units when we're working on the equation. We're just going to use the numbers. Just be careful that you're using the same units throughout a particular problem. Alright, so let's work a problem. 4 liters of an ideal gas at a temperature of 800 kelvins had a pressure of 100 newtons per square meter. If the volume were increased to 10 liters and the temperature reduced to 600, what would the pressure be? Alright, so first thing I'm going to do is I'm going to write my equation. It's P1 V1 over T equals PV over T. These are 1s, and these are 2s. Okay, so 4 liters, that's going to be my volume, 1. So I'm going to put a 4. That's right here. Volume 1 is 4. All right, and then 800 kelvins, that's my temp. So that'll go underneath. Has a pressure of 100 newtons, so that's my P1. So 100 times 4 over 800. All right, and it's going to be equal to whatever happens over here. So we're looking for a pressure. The volume is increased to 10 liters. My volume right here is 10. And the temperature is reduced to 600 kelvin. So that's down here. That's our 600. So I'm going to work as much of this as I can. 100 times 4 is 400. And then that'll reduce to 4 over 8, which would reduce to 1/2. This one I could say divided by 10, and I would have P over 60. All right, now to answer this, all we have to do is cross multiply. So I'm going to have 2P equals 1 times 60 is 60. Divide by 2, and I get P equals 30. All right, pretty easy. You just have to know how to set up the equation. All right, let's see, is there another example? Okay, so this one, the initial pressure of a quantity of ideal gas was 400 newtons, so that's our P per square meter, and the initial temperature was 1200 kelvin, so that's our T. The volume was held constant. That means we don't need the volume one. What is the pressure if the temperature, so we're looking for P, is decreased to 900? That's our T. Okay, so our basic equation is P1 V1 over T, but we're not, it says the volume was held constant, so we're not going to need the V. We're just going to do P over T, P1 over T1 equals P2 over T2. Okay, so we don't need the volume because it's going to stay the same. All right, so our pressure 1 is 400, and our temperature 1 is 1200. And then we're looking for our pressure if the temp is 900. All right, so first I'm going to try to reduce here. Knock off these zeros, and I get 4 over 12, which will be 1, let's see, over 3 equals P over 900. Then I'm going to cross multiply, and I'm going to say 3P equals 900, and then I'm going to divide by 3. And 3 times 3 is 9, so P equals 300. And it would be P2. All right, real easy, just have to know how to set up the problems. The temperature of a quantity of ideal gas was held in an experiment. All right, so our temperature was held. That means we're not going to use T. So if I go ahead and set this up as PV over T, I get rid of the T, and I'm going to have P1V1 equals P2V2. Okay, so anything that was held constant or held in the experiment, that one, we're going to hold it off of the equation. We're not going to use it. All right, the original pressure, our P, is 7 atmospheres, and the original volume is 42. Okay, so we're going to have that times 42. If the volume was reduced to 10, what would the final pressure be? So we're trying to find pressure, and our volume is reduced to 10. All right, so we're just going to multiply here. 42 times 7. And we get 294 equals P times 10, or we could write that as 10P, and then it would look more algebra-y. Go, and then we divide by 10, and our P is going to be equal to 29.4, and that's pressure 2. All right, go ahead and work those practice problems, and I'll come back and work them for you. So hopefully you pause the video and work the practice problems. There are only 2 of them. 8 liters of an ideal gas was at a temperature of 100 Kelvin. So first thing we're going to do is I'm going to write PV over T. Okay, so 8 liters of an ideal gas, that's going to be my volume's 8, was held at a temperature of 1,000 and had a pressure of 200. The volume, if the volume were increased to 10 liters and the temperature reduced to 800, what would the pressure be? All right, so there's my equation. I am going to multiply right here. Then I'm going to divide by knocking off these zeros, and I get 16 over 10, which would be the same thing as 8 over 5. So I've got 8 over 5 equals, I can get rid of this 10 and that 10, P over 80. So now I'm going to cross multiply, and I'm going to get 5P equals 8 times 8 is 64, so 640. Now divide by 5. Uh, 2, 10, 8 times 5 is 40. Pressure 2 should equal 128. 128, yep. And that is the correct answer. So there's the answer to A. All right, before I even read the problem, I'm going to go ahead and set up, it's PV over T. The temperature of a quantity of gas was held constant at 1400 kelvins. So our temperature is our constant, so we're just going to get rid of temperature, and we're going to be using PV equals PV. Okay. The original pressure was 11 atmospheres, so that's our first P, and the original temp was 44. The original volume was 44. Whoops. All right, so pressure is 10, is 11, pressure 11, volume 44. Got that. All right. If the volume were reduced to 4.4, what would the pressure be? P 4.4. Okay, so now we have to solve this. So 11 times 44 That's 484 equals 4.4p. So we're divided by 4.4. And our p is going to equal 484 divided by 4.4. Move our decimal. That'll go one time. And one more time. So you should get 110. And there's the answer to that one. So these aren't very difficult. Just got to know how to set them up. All right, thanks for watching.